Open from 7 o'clock in the morning Central Standard Time to 8 o'clock at night Central Standard Time. So you cover the East Coast and the West Coast guys, and to some extent even the be here because, you know, if you're talking to a guy on the phone and you can't figure out what he's doing, his degree in a camshaft or whatever, you can just go over to this motor right here and kind of figure out what he might be doing wrong and help him out through. Our facilities, our engineering facilities, and we'll get into some of that as we go back towards the back. This right here is obviously the warehouse area. We have a multi-million-dollar inventory. About anything you need. Next, which is more sport compact line. The Walgreens. Everything off the shelf, go to the board, has to make it here, get packaged up. So again, most of these people are here from start about 7 o'clock in the morning. They run about 8 o'clock at night. We keep camcorders for just about everything. Flathead Fords, 235 Blue Flame 6 cylinders, Hemis, old style, new style Hemis, even the new Magnum Hemi motor just come out last year or two in the trucks. We've got cores for those. We're doing camshafts for them. 4.6 Fords, LS1s, Sport Compact, Hondas, you name it, we pretty much got it. Today, if I have one camshaft for, say, a small block Chevrolet or over, with different bearing journal sizes, lobe spaces, with different types of cylinder heads and stuff like that, you've got to have a lot of tools. We've probably got 200 different camcorders just for a small block Chevrolet. The barrel's so much bigger. If you look at the size of these barrels here on these camshafts compared to this here, you can see where it's going to be a lot more rigid. This is for like a pro stock style big block. Standard is 1948, and I think this is like a 2124. I haven't measured it, but my eyes ain't that good, but I think it's a 211. You can see the different lobe spaces, plus you can see how much meat you're going to get here. You can see how it's going to be a lot more resistant to twisting and bending and flexing. This will be better for the better. Actually cast the body, we do all the machine work and all the assembly here.
That's the ones I have.
Yep, Magnums are very popular also. Run all day, they pretty much run all night. They're all automated. Basically, you build the steel up in the back of them, and only get 10 to 1 bar of steel. How it goes through is the order comes out up there, and it goes to the guy that pulls the cam cord. He grabs the appropriate cam cord by looking at the specs. It's got this much duration, this lobe separation, you know, this journal diameter, this bank angle, and this lobe spacing. He pulls the appropriate core, brings it back over here, and then it just stamps to a certain number. This right here's got the grind number on the end of it and a serial number. That tells us what grind to put on there. That serial number tells us everything about the camshaft. Who bought it, when it was bought, what all the specs are, what the grind number comes from, the raw core, the rumper. Now this thing's eventually going to find its way into a rack to finish it. Please let me know.
Some going with that, eh? Well, just look at the operation versus going.
You'll notice the security we got. Let's talk about the cameras. Also got magnetic key cards to get in these places too. One of the nice things about our R&D department, especially working with the big three, is we have pretty good access to about any type of unit that we want. Plus all the motorcycles and chassis dyno for the cars as well. We're going to be doing some testing for Mark Powell there. Bag racing. This is the large one. You'll hear the noise that I've been talking about. Do you have is it a full valve train or just a one cylinder?
All but one valve.
Okay.
It's going to make a lot of noise.
We got 15 valves.
That's just valve train. No rods, no pistons. What they do is they plot the data on the machine. Of course, it's captured, and the engineers take it and go through it, interpret it, do an income design. This is what we're talking about. If you're not busy, if you guys think maybe explain to them a little bit more about it. This is some data out of this motor right here. Lift trace. This is the maximum lift during the RPM. Bounce. As you can see, both the bounce, the amount that the valve bounces, and the lift is definitely a variable over the RPM range. You can see right here about 8,300 or so. I got about a little over 10 thousandths bounce. And then at max engine speeds, 9,700 on this pole, it got up to about 15 thousandths bounce. You can see the lift changes also. The static lift, with the dial indicator was 950 on this run. They got up to an inch 008 during the run, so that probably occurred either right here about 8,500 or looks like it was pretty close again here at 9,700. This is just versus the cycle number.
I'm guessing this is one of the reasons why you recommend we try to put about 100 thousandths between our piston and our valve when we're putting our motors together.
The piston isn't going to hit full lift.
That's where the piston's farther away from the valve.
Yeah. Right. I mean, the intake usually
open.
Right. The exhaust usually tries to hit like 10 degrees before top dead center. When it's closed.
Adco machine. I think all total we probably got about 300 grand plus in the thing now. It's made out of a solid granite base that's probably about 2.5 feet thick. And we would bring that thing in here several years ago. We did our biggest forklift. Hold that thing with about 10 guys in the back of the forklift. It has to be mounted vertically because the machine can actually measure the sag. It'll measure down like 20 decimal places. We only record it down to like 5 or 6. It's actually used in Big 3 and myself, and I think one other company has one like that. These are very, you won't see them. Basically, when the engineer designs the profile, he loads it into this machine here, and this actually checks the design to what it's supposed to be. It doesn't just spit out lifting number. When this thing is finished, it'll have a line graph, and it's actually comparing each load to each term of the design. And if there's a deviation, you'll see it there at the end of the graph.
Are you doing a statistical sampling of your stock as it comes off your CNC machine?
All the custom grind stuff, especially the rollers, come in here and get QC.
100%?
100% of the custom grind rollers. Now, a lot of the part numbers that come off, like the CNC machine back there, the standard part number, we use a military sampling plan. Knows where each load was at, and if you'll notice it moved 3 places across the load. And what that does is it gives you the taper on the load. On your flat pack, it's obviously you gotta have paper. There's loop rotation. On the rollers, you don't want any paper. So if you notice, it'll move 3 places. And it's also got different ends there. You have one right there's on the flat pack. That's for a Winston Cup motor there. I can't tell what it is anymore. They changed it on some other. They used to attach it with 40, 75. Now they all look so close alike. It's hard to tell. But when you run a roller camshaft, they'll swap the followers and roller shop. We got 3 different rollers, hydraulic rollers. The Chevrolet and the Ford are the same size. Hydraulic rollers smaller. 3 different followers and checks. You notice up there the line grabbing the computer screen. That's checking. I forgot each block is. I can't remember if it's incremented. Those high-end stuff. Obviously, we make both machines work. So. Surface finish, there's the pocket there, everything there, all the stuff recorded with serial number as well. We got the hardness testers, so we can check all the corners, got to be checked for hardness, retainers, make sure they go out. We got a computerized valve spring tester down here, which isn't running.